Hey guys, Ms. Davis here. If you're watching this video, you should be watching Unit 11, Skill 2, Two-Way Tables and Venn Diagrams. So please pause the video to write down your essential question. How can we construct and use two-way tables and Venn diagrams to find probabilities? So pause the video, write that down. Okay, before we get started, I just wanted to go over one more time what the new symbols that we learned last time were. So the U shape here, this U shape between two events is the or, and the horseshoe, the upside down U, is the and. So we'll be using them a lot in the next couple of days, so I just wanted to go back over that. So let's read through example 1 and construct a two-way table. So example 1, when a room is randomly selected in a downtown hotel, the probability that the room has a king-size bed is 0.62. So that's our first category, is having a king-size bed. And then the probability that the room has a view of the town square is 0.43. So that's the second category, is having a view. So having a king-size bed and having a view are the two different categories of rooms. Some of them some rooms have both, some rooms have just one or the other. And the probability that the room has a king-size bed, so K, and, so the word and means we're going to use the horseshoe, and a view of the room, so V, not K again, is 0.38. So that's where they should intersect. So our first step is to create a table. So we're going to go ahead and create this little chart like you saw on 1.1, but now we're going to create it ourselves. It doesn't need to be that long, so let's do that, like that. Okay, across the top I'm going to do rooms that have king-size bed, and K prime is going to be rooms that don't have a king-size bed. And then our third column is always the total. And then going along vertically, we've got rooms that have a view, will be V. Rooms that don't have a view will be V prime. And then at the bottom here will be total. And then this box right here, I call it the total. I was right, T for total. And let's go ahead and fill in what we know. So we know that the probability of all the rooms that have a king-size bed is 0.62. So I'm going to come here and fill in for all the king-size probability right here at the bottom. The total is 0.62. So I'm going to fill that in as 0.62. And now we know that the view rooms has a probability of 0.43. So the probability of a room having a view is 0.43. So going across from it here. The other one that they gave us was the and. So the and is always where the V and the K intersect, which is right here. See how they both meet up in that box? Is 0.38. So I'm going to put the horseshoe in there to represent the and. And then our total down here, when we're dealing with probabilities, is always 1.0 or 100% of the data. Now from here we're just going to do some subtraction to find the remaining boxes that are unknown. So we would do, like for the middle box here, we would do 0.43 minus the 0.38 to get this box, and then going up and down we do 0.62 minus the 0.38 to get that box. So I'm going to go ahead and pause the video and fill in the remaining numbers. Okay, and just to double check, so these are the numbers that should go filled in, and if you add down this column, they should equal 0.62, add down this way, equal that, add down this way should equal 1.0. Same with going horizontally. These numbers should add up as well. Okay? All right, so now we're going to use this table to answer some questions about probability. So as we read through example 1, or part A, it says, what is the probability that a randomly selected room that has a king-size bed, so this is our given, that has a king-size bed also has a room or a view of the town square. Okay, so we're given K, but we're finding the view rooms within the domain of K. So we're finding the probability of the rooms that have a view, given that they also have a king-size bed. Okay, so I always look in the given column. So the given column at the very bottom, the total probability for king-size bed is 0.62. That can go on the bottom. So the given goes on the bottom. And then from there, we want to look, okay, well, of this column, how many of them have a view? The 0.38. So we're going to fill in 0.38. Okay, now to rewrite our probability without the decimals, we just want to move those decimals 2 back to the right and write it as 38 over 62 without decimals as a probability. Okay, next question down. It says, what is the probability that a randomly selected room has a king-size bed, so K, and a view of the room, V, a view of the town. So we're finding the probability, so P of K and V. Well, if you look at your table, I already drew it in there. The intersection point is just 0.38. So 0.38 is the probability of both of them occur, so it's going to be 0.38. And then when we do or and problems, they're always going to go over the whole probability of all of it put together, which is 1.0. So 1.0. And if we rewrite that as a fraction with our decimals gone, it will be 38 out of 100. Okay. All right. Example number, or letter C, says, what is the probability that a randomly selected room has a king-size bed given that it has a view of the town square? So we are given that it has a view. So how we write this would be the probability that it has a king-size bed given that it has a view. Okay, so looking up at our table, here's our fraction. Always look in the given column. So our given is going to go across this way. So the total room probability, the probability that the room has a view is 0.43. So that'll go on the bottom for your given. And then the top number within the V column, or row rather, where how many of them have a king-size bed, or what's the probability of having a king-size bed? The probability would be 0.38. Okay. All right, and then just rewrite that as 38 over 43. Okay. Moving down the page here, on our last problem, it says, what is the probability that a randomly selected room has a king-size bed, or, so king-size bed, or has a view of the town square? So in this case, that is not shown in the table, and there's some other work that we could do for that to find it, but there's a formula that we want you to know and kind of memorize here, is that the OR of two events is equal to the probability of the first event plus the probability of the second event minus and subtract off the and, or subtract off the intersection of the two. Okay, so when we put it in terms of this problem, we're going to do probability of king-size bed or probability of the view is equal to P of K plus P of the view, so probability of king size plus the view, subtract off their intersection of K and V. Okay, so P of KUV, we're going to fill in what we know. Well, we know that the total probability of having a king size bed is 0.62. That was given in the word problem, plus the probability of having a view is 0.43. minus the intersection and. So the and we had right here found was the 38. So 0.38 we're going to use though. So subtract off the 0.38. And then when we type that into the calculator, you're going to get a decimal of 0.67. And we always want to write the or the and problems over 1.0. So then we can rewrite it as 67 over 100 as your probability. Okay? All right, go on over to the next page. Okay, so for example 2, I already set up the chart and drew it in. We've got two things happening. C is the customer being long-term card holder, and B is the customer paying their credit card bill in full each month. So our two things were C going this way, C and not C, and then B and not B. So paying their credit card bill on time and being a long-time card holder. Okay, then I filled in what we knew, or they gave us. So our probability of C total in this column going across was 0.42. So I converted that 42%, divided it by 100, and wrote the decimal version. Then the probability of B going down this way was 0.35. And then I also filled in the total needs to be 1.0. Okay, so so let's see if there's anything else that we can fill in from here, what we are given. So the only things we can fill in is that this one right here is 0.58, because going up and down that needs to add up to that total, and then going left and right here, this needs to be 0.65 to add up to 1.0. There's no other way that we can get the 4 numbers in the middle. So in this case, they give us something else called, this is the OR, right? So they give us the OR is, and the OR, what's going on here? The OR is, won't let me write, hang on, is not in the table. So, but what can we do with it to help us get more numbers? So we remember this formula that we talked about on the last page right here, the OR. But what we can do is we can just switch up the and in the or and write it as, so if I added the P of A and B and added it to the other side and kind of switch them up, we can use the formula probability of A and B is equal to the probability of A plus the probability of B minus the and. Or sorry, minus the or. So I can write it like that and switch those two and the and around. Because now they give us the or. So the or is 54%. So when I plug this in, I can plug in the or is 0.54 over here. And I know the probability of, in this case, let's change these to C and B, right? So let's change these to C and B, probability of C and B, which the B was already there. But we've got the probability of C is 0.42 plus the probability of B was 0.35, and then subtract off the or will give us the and. So it'll be probability of C and B. Okay, which is going to go right there once we can find it. And once we have that number, we can fill in the rest of the chart. So go ahead and type those 3 things into your calculator, and you end up with 0.23 is the and. So P of C and B, which is going to go 0.23 is the intersection. Okay? All right. So for a Venn diagram, you're going to use this to help fill in the chart. But on the Regents exam, they might just ask just for the and, might ask for the and given the or, and then this is when you need to use formula because it's a lot less work than setting up a whole table. Okay, so then from here, I'm going to pause the video and fill in the other values now that we can find out. Okay, so take a moment to fill those in, and now let's answer some follow-up questions. So what is the probability that a randomly selected person that pays their bill in full each month, so that is B, given B, is not a long-term card holder. So is not a long-term card holder, wow, can't talk, would be C prime. So we're finding the probability of them not being a card holder given B, that they pay their bill in full each month. Okay, so looking in the given column, in the B column, we've got 0.35 on the bottom. So 0.35 on the bottom, and of this column here, how many of them are not card holders? 0.12. So 0.12 on the top, rewriting that as 12 over 35. Okay, all right, scrolling down a little here. Part B, what is the probability that a randomly selected person pays their bill in full each month? So B. And, so we're doing the and is not a card holder, so not C. So we're going to find the probability of B and not C. So looking at our chart. Okay, so looking back up at the chart, we've got where do B and C prime meet up? So we've got, they're not card holders in this column, and they pay their bill in full in this column. And where do they meet up? Well, B and C prime intersect or meet up. This point 12 represents both B and C prime. So it'll just be point 12, and when it's an AND problem, remember always to put it over 1.0, which will be 12 over 100. Okay? All right, part C. I hate when it does this. Okay, part C, we've got, what is the probability that a randomly selected person pays their bill in full each month? So pays their bills in full each month, given that they are not a long-term card holder. So given C prime. So it'd be the probability that they pay their bills in full each month, given that they are not a long-term card holder. Now this one might look very similar to the one above it, but this one we were finding the intersection of the two. Now this one we're actually looking in the given column, so we're looking given C prime, so if I can scroll up here without an issue, nope. Okay. Given in the C prime column, so right here, it'll be 0.58 on the bottom. So when I come back down here, it'll be 0.58 on the bottom is the given, and within that column it is 0.12 of them, or 0.12 is the probability that they pay their bill in full each month. So rating it as 12 over 58. Okay. All right, then the last question says, what is the probability that they pay their bills in full each month, B, or is not a long-term card holder, C prime. So we're finding P of B or C prime. Well, using that formula that we have been learning about this video, we're going to do the probability of B total plus the probability of C prime total and subtract off the probability of their AND. So C and B and C prime. Okay? So when we do this, the probability of B paying their bills in full is 0.35 plus the probability of C prime total, if you look up at the chart, is 0.58 minus their intersection of the two. So where they meet up in the chart is 0.12. Okay? So then when you plug that all into your calculator, you end up with 0.81, which turns into 81 over 100. Okay? All right, flip on over. One more problem. Okay, so for this one, you are given a Venn diagram, and there's a scenario. Jessica did a survey of a group of 9-year-old boys about whether they had played basketball or football. Using the results displayed below, answer the following questions. So we have to know how to interpret this chart, okay? So first of all, the 1-8 on the outside here is neither. They played neither sport. Okay, so not basketball, not football. The one in the middle, the 12, represents the AND, or they played both sports. Okay, so if we were to find the total of students or boys that played basketball, I'm going to highlight this ring in green. So the total basketball players is actually going to be not just 52, it's going to be 52 plus the intersection of 12. Okay, so the total basketball players, I'm going to change colors here. So total, basketball is the 52 plus the intersection of 12, which is going to be 64. Okay? So now on the other side, looking at the football circle, all the boys that fit in the yellow circle play football. So when I go to find the total football players, I'm going to do this over here. is equal to the 12, the intersection, plus the 63, which is 75. Okay? So those are really important to know as we go to set up the Venn diagram. So we're going to create a Venn diagram from here to model this information. It's just a lot easier to look at and easier on the eyes. So I'm going to set up the chart. I've got basketball and not basketball at the top, and total. And then I've got football and not football, and then total. And then we've got the total football players is 75 players, and then the total baseball players down here at the bottom is 64. And then the intersection of the two, so this is the football and basketball players, is 12. And then how many students are there total within this survey? Well, the total is going to be equal to the 52 that play basketball, plus the 12 that play both, plus the 63 that play just football, plus the 8 that play neither. Okay, so the total, when I add those all together, is 135 is the total. Okay, so that's going to go over here, 135. So from here, we can fill in the remaining numbers. So go ahead and pause. Okay, so go ahead and fill in these numbers. And pause the video if you need to. But just to reiterate, the 52 here are the students that just play basketball and not football. These guys, the 63, are the ones that play just football and not basketball. The 12 are the ones that play both. And the 8 on the outside is the one that play neither. Okay, so now let's answer some follow-up questions. So we've got, what is the probability that a boy has played basketball and football? So we've got B and football. So what's the probability of B and F? Well, if you remember, looking in your chart is just where they intersect again. So we've got 12, but this time it's 12 not out of 100 or not out of 1.0, it's out of the total. So 12 out of 135 students or boys play both. Okay. Part B, what is the probability that they have played basketball or football? So now we're going to do P of B or the football. Okay. So how you do that is you find the probability of all basketball, so that would be the 64, plus all football is 75, minus the intersection of 12. Okay, and as you can see from the Venn diagram, if I added 64 plus 75, this 12 in the middle is going to repeat. Those players are going to be in both categories twice, so they're going to count twice. So that's why we subtract off the intersection or the and, because you don't want to count those players 2 times because it's the same guys in both teams. So again, all over 135. So when we subtract, we get 127 over 135. Okay? All right. Part C, what is the probability that a boy has played football given that he has played basketball? So probability that he has played football given that he has played basketball. So looking in the given column, so B is 64 on the bottom for the total there. And then of those, of these guys that play basketball, how many of them also play football? 12. So it's 12 out of 64. Okay. And then our last one is, what is the probability that a boy has played football given that he has not played basketball? So B prime. So probability of football given that he has not played basketball. So looking at the row or column for B prime, down here at the bottom, 71 have not played basketball. So that goes on the bottom. So we get 71. And then of those guys, how many played football? Well, if you look back up at your chart, 63 in that column out of the 71 have not played basketball. Okay? All right, so do your practice. Use your notes. use your OR formula, use your AND formula, and go.